Good morning and welcome back to the next section of Chapter 3. In this section, we are going to be looking at solving systems of linear inequalities. So we're going to be looking at inequalities, not equations. We will be solving these by graphing. That's really the only way to solve a linear inequality, because the answer is the graph itself. We will take a look at that. And the nice thing about this is that it's just like graphing the inequalities we did last chapter. It's just like graphing equations, except we have those two things to think about: solid or dotted, and which side we shade on. So let's take a look at our learning target for the day. There's only one of them. I can solve systems of linear inequalities. I love it when it's the same as the topic. So to solve a system of linear inequalities, first we need to start out with the inequalities. We have 7x minus y, or is less than y minus 16. And y is less or equal to negative 5x minus 2. So for the first one, 7x is less than y minus 16, let's get this into slope-intercept form. Because we could find intercepts, but I'm seeing if I'm plugging 0 for y, I'd have x equals negative 16 sevenths, and that just sounds obnoxious. So let's add the 16 over to the other side. We get 7x plus 16 is less than y. And then let's flip the whole equation around. So we have y on the left-hand side, because that's what we're used to. We're used to like y equals. Y is greater than, y is less than. So when we flip it around, notice the sign, the bigger end was towards the y. The bigger end is still towards the y. The sign flipped with the equation. And so that tells us we have y-intercept of 16, slope of 7. So if we have our graph, we are going to start out with a point at the y-intercept, 16, and then the slope is 7. We can go up 7 over 1, but that takes us off the graph. We're starting at 16. So instead of going that way, let's go down 7, backwards 1. Down 7, backwards 1. And we can connect the dots. And then, it's just a greater than. Well, it's a good thing we have our little dotted line maker here on our pencil, and we can change that into the dotted line that was supposed to be. How many of you do exactly that? It's not a problem, but that's why we use pencil, not pen. Then for the other one, it's already in. Then shading. We shade this side, because if we plug in a point, let's say the point negative 5, 10. So 10, let's see, negative 5 times 7 is negative 35, plus 16 is a negative number. 10 is bigger than a negative number, so we shade that side. For the other one, it's already in slope-intercept form. So we can start out with our y-intercept, negative 2, and we can go down 5 over 1, but that's again off the graph. So let's go up 5, backwards 1. Up 5, backwards 1. We can connect the dots. This time it is supposed to be a solid line. We can plug in a point. We have 0, 0 right here. Is 0 less than negative 2? No, it's not. So points over here should work. We could plug in negative 10, 0. Negative 10 times negative 5 is 50. Is 0 less than 50 minus 2? Yes, it is. So we can shade that side of the graph. Now, where do you think we're looking for our solution? We are looking for where the shading overlaps. So, this area. So notice when we shaded in the beginning, I shaded very, very lightly. That way, we can shade dark when we see it. If you shade everything really dark, it's going to be hard to graph the other lines. So I would shade things lightly. Then you can take the overlap and shade that in. So that's how to solve a system of linear inequalities. We graph the lines. It may ask us some other questions. It may say, find the shaded region and then find 3 points that are in the shaded region. There are a lot of points out here. Just pick 3 of them. I would pick them not near the lines. It's like I wouldn't pick this point right here. I would pick negative 5, 0, negative 10, 4, negative 100, 15. Like, those are really, really easy points. They're definitely in the shaded region. So we can do it again, but sometimes it'll say graph the system and classify the figure. Now, classifying the figure is not like classifying the system where we had parallel and independent and consistent and anything like that. It would be, what is the shape that it makes? So here we have a system with 3 lines. What shape do you think 3 lines are going to make when we graph them? If you said a rectangle, think again. A triangle. We are probably going to get a triangle when we graph these. So we can look, they're all in slope-intercept form except for this top one, which is just x equals, it's a vertical line. So we don't need to mess with the equations. But let's color code. Let's use blue, red, and green. We can get our graph. So the blue one, x is less than or equal to -1. So we go to -1. We're going to get a vertical line there, and then it's less than that. Well, less than is going to obviously be here. These are when x is less than. So we shade that way. Again, shade very lightly. You may also want to shade just a little bit on the side of the line. That way you don't cover up the whole graph. And then the next one, y is less than or equal to 3x plus 2. So we start out at plus 2, and then up 3 over 1, up 3 over 1, make the line, and then shade. So we could plug in 0, 0. Is 0 less than 2? Yes, 0 is less than 2, so we'd shade that side. And so far we have this area. And then y is greater than or equal to -3x minus 10. So let's start at -10. And then we can't really go down 3 over 1, so let's go up 3, backwards 1. Up 3, backwards 1. Connect the dots. The 0, 0 is a good one to plug in here. Is 0 bigger than -10? Yes, 0 is bigger than -10, which is good because we would want this section. And so where they're all overlapped is this shape right here, which, as we expected, is a triangle. And so we can shade that section a little bit darker. And that would be solving the system of, or that would be graphing the system and classifying the figure. Now if it has 4, and this would be an isosceles triangle, these two sides are the same. If there's 4, it could be a square, it could be a rectangle, it could be a parallelogram, rhombus, kite. There's a lot more options there. So you can't just be like, oh, it has 4, it's going to be a square. No, you actually have to graph it. Sometimes it'll go backwards. It'll say graph, or give the system of equations that will graph a square. You could do that using like difficult equations that are angled and perpendicular, but remember you can also use horizontal and vertical lines. You don't have to make it super hard, but you can if you want to. Other than that, that's what we're doing. Same thing, we're just graphing lines, shading, and it's where the shading overlaps. So make sure you do the task that you're supposed to do after this, and I'll see you next time. Until then, happy mathing.